So let's continue. From this formula, the I sub s, which is according to this is from textbook for values factor of the length, the base, the height of the natural grade line to the footing, base of the footing, and the Poisson's ratio of the soil. So this is I sub s is a shape factor. So this is from the table from Brahadas. You have to determine the value of the, if it is in the corner or center of the foundation. So the M prime is L over B and the N prime is H over B over 2. If it is at the corner, if you are asked nga pangitawon ang settlement at the corner of the foundation, then your M prime is equal to L over B and your N prime is H over B. So this is given the table, this table here. Then you try to find the value of M and N, then trace what is the value of your I sub S or the shape factor. Then substitute in this formula. So we have here in table 11.4 representative values of the modulus of elasticity of soil. So we have here the soil type from soft clay to the dense sand. So kuan gid siya gamay gid siya modulus of elasticity ang soft clay. Then highest is the dense sand. Also a table for the representative values of the Poisson's ratio for type of soil, loose sand to medium clay, Then this is the range of their Poisson's ratio. So yes, for rigid foundation settlement is approximately equal to 0.93 settlement if at a flexible and center. This one is flexible and wala naka-indicate. SE. Then yes, this is the settlement at a flexible foundation. Due to the non-homogeneous nature of soil deposits, the magnitude of the modulus of elasticity may vary with depth. For that reason, Bowles 1987 recommended using a weighted average value of of the modulus of elasticity may vary with depth. So this is the modulus of elasticity, which is the summation of the soil modulus of elasticity within a depth delta z over bar delta z, where bar z is equal to bar z is equal to h or 5b, whichever is smaller. Okay. Sorry, I stand corrected again. H is the height from base of the footing to the soil, the pervious soil, sa specific layer, at a particular layer. Then this is the variation or the formula for the varying modulus of elasticity. So this is the representation. So we have here the foundation, then is external load, then we have the height, then rock na dayon ang underneath aning soil, then we have the varying modulus of elasticity, no? Okay. The immediate settlement according to Chilcher, ever, the vertical settlement under uniformly distributed flexible area is this formula where I sub p is the influence factor which dependent upon elastic properties of base and shape at base. So this is the actually formula, no, of the I sub p, or the influence factor, where m sub 1 is the length of the foundation divided by the width of the foundation, no, or L over B. But this I sub p can be found in table, no, automatically, like this, no, in table 10.1, the influence factor for foundations, no. Yeah, you just have to find the value of your M1, then what is the value of your IP, depende kung what is asked in the problem, if it is center, corner, or inflexible, if it is a center, corner, then, or if the foundation is rigid, no. This is the representative values of the modulus of elasticity of soil. Magbalik na ni ganina. So this is your I sub P. This table can help, no, in finding your influence factor in this formula. This is actually the same with this one, no, almost the same with the previous one. It is just that dalahi ang ilahang shape factor. This one uses the shape factor I sub S and I sub F. This one is only I sub P, the influence factor, no, in this formula, but can be found in the table. We have here an example. Estimate the immediate settlement of a column footing 1.5 meter in diameter. It is constructed on an unsaturated clay layer, given that the total load carried by the column footing is 150 kilonewton, and the modulus of elasticity of the soil is 7,000 kilonewton per meter square, and the Poisson's ratio is 0.25. Assume the footing to be rigid. So we have to find, we have to use this formula, no, for the immediate settlement. So to find the delta, no, the external pressure, this should be P divided by the area of the footing. Remember that the column footing, this column footing equal to 1.5 in diameter. So P divided by the area, no. So this is the delta sigma, or the external stress, no. Then from table 10.1 for circular rigid foundation, let us try to find for circle. This is circle, since the foundation is circle, then as stated in the problem, the foundation is rigid, so meaning diri nga table, no. Therefore your I sub P is 0.79, which is 0.79. Then substitute the formula, no, this one, substitute the formula using I sub P 0.79 and the value for the delta sigma, which is 84.9, times the P, no, B, this is the characteristic length of the loaded area. So remember, the foundation is circle, then characteristic length is actually the diameter, no. So this is the B of your circular footing, meaning circular footing, there is a column at the center, no, but the footing is circular. So manang your B here is 1.5 in diameter, or this is the diameter, times the quantity 1 minus Poisson's ratio divided by the modulus of elasticity, which is given 7,000 and 0.25. So this is your answer for the immediate settlement. No, we have here the improved relationship for immediate settlement. No, of course we have different scientists no nga mo discover or mo formulate, so mo nang doing some research also. So we have here a somewhat modified no or improved relationship for immediate settlement. So natay kani nga formula then daghan na dayon kay influence factor or correction factor or something, no? Another is part of the improved relationship for immediate settlement. We have the B sub E is equal to the square root of 4BL over pi, where B is the width of the foundation and L is the length of the foundation. For circular foundations, BE is equal to B, where B is the diameter of the foundation. No? Okay, B sub E. We have B sub E, which is katong gamiton diri, no? We have B sub E. And yeah. You have primary consolidation settlement, or this is S sub C, no? Which is the in the second term, no? So what we discussed earlier is the immediate settlement, or is S sub I. So we have here the primary consolidation settlement, which is time dependent. So for a longer time, no? And then we have here the representation of behavior of the primary consolidation settlement. So it is represented by the spring cylinder model. No, we have here the at initial stages, meaning the time is equal to 0. Then there is delta U, or this is the pore water pressure. Then we have here a spring and I think this is water. Then we have a closed valve. So for this one, the total stress is equal to the pore water pressure, you know, and the effective stress is equal to 0. Then we have here a load. No, there is a load already in the second figure. Still the valve is closed. Then the pressure here, or yes, the pore pressure here is equal to the load applied divided by the area, no, this area. Then at a certain time to infinity, no, wala ta kabalo kung kano sa mahuman ang primary consolidation settlement. Then there is this valve here is already open, no, meaning the total stress is equal to the effective stress. There is an effective stress plus the pore water pressure. And because gi-open na nimo ang valve, there is what we call a consolidation. Mugawas na ang tubig, no? And that is why your delta, this can be the end of primary consolidation. This can be equal to 0. So that is why your total pressure here, total stress is equal to the effective stress, no? And after some time, because of the valve opening, then stretch ang spring kay ni consolidate naman, nawala na ang tubig, no? After such time nga delta mu pore pressure here is equal to 0. Then this is the end of the primary consolidation. We have here analogy, no? The soil is equal to soil solids plus water, and analogy in this representation is equal to the soil solids is spring plus the water. So we have here a spring and a water, no, plus water. There is no load, no drainage, and no volume change. Then there is application of load. Then there is load, but because the valve is closed, so no drainage, no volume change, and no stress in spring. And after kuan, there is load, no, but you open the valve, meaning there is a drainage and the volume change. The spring is stretched, but of course you have to comply the equilibrium still. Then no more water loss after some time. No more water loss. Then consolidation ended. So the um the stress, no, is equal to, because of the equilibrium, is equal to the stress in spring, no. The pore pressure or stress is equal to the stress of the spring. Still, primary consolidation, di kaya siya maklaro, but this is the same with the concept earlier. This one, no. So, like this one, we have a total stress increase. Then after primary consolidation, there is consolidation. Then ni squeeze out ang water, then the delta U or the pore water pressure is equal to 0. Then the effective stress is increased, so the total stress, since na 0 naman ang pore water pressure, is equal to the effective stress. Alright. We will discuss this one.